So welcome to this problem set for theories of failure. So we'll start with the very basic, that is using the Morse circle. So problem number 1, at a point in 2D stress system, the stress element on the x-axis is equivalent to 100 newtons per millimeter squared, and the stress element on the y-axis, which is equal also to the shear stress, is 40 newtons per millimeter squared. What is the radius of the Morse circle for stress drawn in a scale of 1 centimeter equivalent to 10 Newton millimeter squared? Again, we have these steps extracted from our reviewer if we are going to use the Morse circle. So not really these formulas, since ang hinahanap is circle, but these are useful relationship in order to arrive with the correct answer. So lagay lang natin yung figure and data. Figure and data. So first is lagay natin yung mga stress element dun sa x and y coordinate. So this one is x, normally positive in this direction, and then y also positive in this direction. So yung ating x normally is represented by the tension. So let's take this as 100. This one is 50. So 100 Newton per millimeter squared. And then meron tayong 40 na y. So this one is 50. This one is approximately 40. Ito yung ating point na 40. Okay, so lagay lang natin yung ating element. And this one is again stress element on this x-axis, that is tension, 100 Newton per millimeter squared, and meron tayong positive here is 40, that is the stress element on the y-axis. So pwede natin sabihin din na compression yan in this direction. So meron tayong shear stress. Normally pagka positive, again, remember that sa sign convention natin, if you are going to this direction, we have this as positive, and then ito is positive then. Going up is positive, and positive multiplied by positive is positive. So we have 40 Newton per millimeter squared here. Pag ganito, so this one is negative going to the left, and then ito is positive. So positive multiplied by negative is negative shear stress yung representation dito. Ganun din dito. This one is positive, this one is negative. So negative multiplied by positive is negative. Alright? And then here we have the same. So in order to represent this in equilibrium, ito yung ating stress, by the way. Para may equilibrium, pwede mong lagyan ng ganitong sign. Alright? So, the first step is to construct axis for Morse circle. Again, nasa stress element pa lang tayo. So, in order to plot yung stresses na yan sa ating principal stress diagram and then shear stress. So take note, going to this direction using Morse circle, this one is still positive, but usually karamihang reliable books, yung pababa is positive. Okay, so this one is positive. Going up is negative for the shear stress. And this one is 0, 0. So now, let's represent yung ating normal stresses. Again, take note, yung tension and compression are normal stresses. So pagka 100, this one is 0, 0. This one again is 50. This one is 100. So ito yung ating point na yan. So this one is stress element on the x-axis. And then meron tayong 40, positive 40. This one again is 50. This one is 40, which is actually yung ating stress element on the y-axis. Okay, so again, 40. And then shear stress is 40. Another 40 here. So pagka ratio in proportion natin, we have positive here, 40. Okay, positive. And then may corresponding negative yan dito. So this one is negative 40. So kung ipa-plot natin, kukonect natin yung two lines, tapos ito is 100, ito yung magiging point natin. So 100, that is x and y arrangement again. So 100, this point is represented by 100, and then 40. Yung y natin is 40. And then here, meron tayong x and y arrangement again. We have 40, that is the normal stress, and then negative 40. So ito yung ating pinaka-point. Now, next procedure is to connect. So, nasa step 3 na tayo. Okay, so na-plot natin yung ating normal stress and shear stress doon sa ating plane. Now, we will join X and Y and draw a circle. So, straight line lang. So, gamitin natin ng ibang color. Okay, so ito yung ating pinaka-diameter. And this one is represented by our center. So, pwede nating i-project yan na ganito yung ating circle. So, the center, pwede natin malaman using inspection or this relationship. Okay, that is the average stress. That is the normal stress on X and Y axis. That is stress element on the X axis and stress element on the Y axis over 2. And then, lagay lang natin yung values. 100 plus 40 over 2. That is 100 plus 40 is 140 over 2 is 70. So, this means that meron tayong 70 dito. Normal stress. And then the radius, pwede natin malaman or makuha yung value ng radius using this relationship. But then, pwede rin namang by inspection. Kung alam na natin yung center dito, pwede natin i-plot yan. So, kunin natin, extract natin itong part na to. Alright, so ito is yan. So, if this one is 70 and this one is 100, so ang part na to is 100 minus 70. That means itong distance na yan is 30. 40. Okay, so this means makakuha ko yung value nito from this point, from the center to here. That is equivalent to the radius. And the radius, using Pythagorean theorem, pwede natin gamitin itong relationship na to. 30 squared plus 40 squared. That is x squared tapos y squared. Tapos kunin natin yung square root. So, very basic. So, 30 squared plus 40 squared. Equal sign. So, we have radius of 50. Okay, so pwede natin i-double check yan using this relationship. Again, or r is equivalent to the square root of x tapos y over 2 squared plus the shear stress squared. So, direct substitution na lang to. We have the square root of, open ko muna, and then we have 100 minus 40 tapos over 2 squared plus shear stress is 40. Cosine, so we have 50 newtons per mm squared. So, again, ang question dito is yung radius. But in terms of scale, so kung ang scale is 1 cm is equivalent to 10 newton per millimeter squared, thus the radius in terms of centimeter is blank. So, radius is 50 newton mm squared. Tapos, ilagay natin yung scale, no? 10 per mm squared. Equal sign. So, 50 over 10 is 5 centimeter. Okay. So, again, 10 newton per millimeter squared per centimeter or 1 centimeter. So, this is the answer. Alright. That is letter C. Alright, determine the magnitudes of the principal stresses for the following state stress. That is, the stress element on the x-axis equivalent to 30 megapascal and the stress element on the y-axis is equivalent to negative 10 megapascal and the shear stress is given equivalent to 25 megapascal. So, we can solve this problem using the Mohr circle again. So, let's start. Step number 1 is to construct the axis for Mohr's circle. So, let's first draw figure and data. Figure and data. Alright. So, lagay muna natin yung ating mga stress element on X and Y axis. So, this one is X and this one is Y. So, pagka nalagay natin yung ating stress element dito sa plane na yan, okay, this one is represented by tension. That is stress element on the x-axis, 30 megapascal. So, this direction is positive, while this one is plus, pataas plus. But then take note, the value of the compression or the stress is negative. So, that means compression. So, this one is negative 10 megapascal. And then the shear stress is 25 megapascal. So, again, we can represent this here, 25 megapascal. Ang technique, take note here, nakita natin, is going to this direction is positive. So, this one is positive. And then, pataas naman, yung y direction natin is positive going upward. So, this one is positive. So, positive multiplied by positive is positive. So, ito yung ating representation, 25 megapascal. Now, step number 2 is we are going to construct yung ating Mohr circle. So, normally, itong x-axis natin dito kanina is pinapalitan natin ng principal stress, while here is the shear stress. And take note, this direction is positive normal stress, and then yung pababa naman here is also positive. In this case, negative yung pataas. So we can plot yung ating normal stress. Take note, yung 30 megapascal can be represented as tension, and then yung negative 10 megapascal is compression, as you can see here, pababa. So, both yung compression and tension stresses are normal stress, as we know. Okay, so 30 megapascal, saan yan? So, let's take this as 15, and this one is 30. So, ito yung point na yan. And in this line, again, remember that the shear stress here is 0, or the maximum shear stress is equivalent to 0. And then, meron tayong negative 10. If this is 0, 0, we can say ito yung 15, ito yung 10, ito yung ating point na yan. So, this one is stress element on the x-axis or the tension, and this one is compression, negative 10 megapascal. Now, for the shear stress. Shear stress is 25 megapascal. So again, this one is 15. This one is approximately the 25 megapascal. And of course, may corresponding negative value yan. Okay, so this one is also equivalent to 25 negative megapascal shear stress. Alright? And then, we plot the x and y components. Ito yung ating x and then y. So, ito yan. Connect natin yung ating stress. Ito yung point, isang point sa ating circumference ng Mohr circle. Ganun din dito. Try natin connect. This one is 30, x and y arrangement na naman, and then vertical is 25 megapascal. Ito yung point na yan, while this one is x and y arrangement. So, ang x is normal shear stress, so negative, and then here, negative 25 megapascal. And then step number 3 is to join x and y and draw a circle. Okay, so, lagay ko lang yung ating straight line. So, ito yung pinaka-diameter ng ating Mohr circle. And then, from here, so ito yung pinaka-center niya, okay? Lying on the principal stress axis. So, pwede natin gawing, or pwede natin i-project yung ating diameter. So, let's take this as perfect circle. So, take note, step number 4 is locate for the center of the circle with this relationship. So, center basically is the average ng ating normal stress element x and y over 2 lang. So, madali lang yan. So, solution, dito ko na nalalagay. So, center is this one, stress element on the x-axis, and then y over 2. In this particular case, we have 30. Okay, and then plus, take note, meron tayong negative dito. Negative 10 megapascal over 2. So, that means, meron tayong 30 minus 10 is 20 over 2 is 10 megapascal. That is the center. Ito yung value niya, 10 megapascal. And then the radius is actually pwedeng by inspection. So, if this one is 10, and this one is 30, so, this means that mayroon tayo ditong 20 megapascal. From this point to this point, again, is 25. Tama? So, pagka in-isolate natin yan, we have this illustration. So, 20, and then meron din tayong 25. Okay. Radius can then be solved using the Pythagorean theorem. Okay, so, paano yan? So, we say here na to get the value of r, ito yung ating equivalent radius. Okay, so that is the square root of 20 squared plus 25 squared. So, r, or the radius, is equivalent to blank. So, square root of 20 squared plus 25 squared. Okay, so 32.01. 32.01 megapascal. Again, that is the radius. Or pwede mo rin gamitin ito. Okay, so pakita natin so that ma-master. So again, 30 minus 10 over 2, and then you have to square plus the shear stress of 25 megapascal. So pakita lang natin. Open, and then 30 minus negative 10, tapos 2, and then squared plus 25 squared. Equal sign. So we have 32.01. 32.01 megapascal. So, the same, nakuha natin using Pythagorean theorem, or by inspection, and then yung derived formula. And take note, again, yung center natin is equivalent to the average stress. And then the R is equivalent to the maximum shear stress. So, pagka nirotate natin ito, okay, this one to here, still it's a radius, but then makakuha natin yung maximum shear stress, which is 32.01. Now, ang next is to calculate the principal stress. Okay, so to calculate for the principal stress, we have to use this equation. By the way, this one is 2. This one is the maximum principal stress, and then this one is the minimum principal stress. So, pwede natin gamitin yung relationship na yan. So, maximum principal stress equals sign. So, that is the center plus the radius. Ang center natin again is 10 plus the radius as calculated is equivalent to 32.01 megapascal. Therefore, we have 42.01 megapascal. Now, for the minimum, we just use yung same relationship, but this time minus 10 minus 32.01. Therefore, we have 22.01 megapascal. Okay, so ito yan. Alright? And then, the maximum shear stress is equivalent again dun sa radius. Again, by inspection, kanina, no? So, pagka nirotate mo yung radius, makakuha mo yung value na maximum shear stress dito. So, that is 32.01 megapascal. So, ito yung pinakasagot natin. 42, 22, and 32, which is letter A. Now, pwede natin gamitin ulit to double check yung ating derived equations. That is, yung ating principal stress, maximum and minimum is equivalent to the average stress ng stress element over 2 plus and minus the square root of same value over 2 squared plus the shear stress squared. So, positive will result to the maximum, and the negative naman is para dun sa minimum principal stress. So, pagka kinuha natin yung ating maximum, we'll just use yung positive, okay, over 2 plus this one, okay, and then over 2 squared plus xy squared equal sign. So, substitute the values dito. We say that we have 30 plus minus 10 over 2 plus, again, 30 minus 10 over 2 squared plus 25 squared as given. So, we have 30 minus 10 over 2 and then plus square root of open. Tapos 30 minus minus is plus 10 over 2 and then squared plus 25 squared equal sign. We have 42.01 megapascal, which is this one. Okay? And then sa minimum naman, simple. Gagamitin lang natin yung negative. So this one, let's make this simple. So same calculation, buburahin ko lang yung positive. That's the beauty of this calculator. Madali i-delete or paltan. Dapat ito ay minus. Equal sign. We have 22.01. So, negative 22.01 megapascal. So, by the way, this one is negative. That is, 10 minus 32 is negative 22. And then, maximum is equivalent to this part only. Okay, so pagka tingnan natin yung notes para makuha yung maximum shear stress is equivalent to this formula or relationship. So, pwede kong burain ulit yan. Okay, so that we can solve for the maximum shear stress. Equal sign, this must be 32.01, equivalent to maximum shear stress, 32.01 megapascal. Again, take note, itong until here, we use yung Moore's circle, and this one is basically derived equation. Alright, so the answer here is letter A. Alright, problem number 3 for theories of failure. A solid shaft of the diameter 30 mm is fixed at one end. It is subjected to a tensile force of 10 kilonewtons and a torque of 60 newton meter. At a point on the surface of the shaft, determine the principal stresses. Okay, so figure and data. Okay, so we have a combined stress here. So, pwede tayo magkaroon ng shaft. Okay. Draw lang natin. So, let's take this as our shaft subjected to torsional stress. Okay, torsion value is 60 Newton meter. Tapos meron tayong tensile force. So, lagyan natin yung tensile force na 10 kilonewtons. And the diameter is given. D is 30 mm. So, we have a combined load of tensile and shearing stress due to torsion. So, now, determine the principal stresses. So, this one is simple since nakapag-solve na tayo kanina ng ibang problem. Kaya lang gusto kong i-relate yung tensile tapos yung shear doon sa ating principal stress. So, paano natin ma-solve yan? So, solution, to get the principal stresses, first is kunin muna natin yung normal stress. That is, stress due to tension is equivalent to force over area. So, meron tayong force na 10 kilonewton. Since shaft yan, so we assume na perfectly circle. Ito yung ating diameter again. So, that is pi over 4 to get the area, d squared. So, 30 mm is 0.03 meter and then squared. Equal sign. So, we have here kilonewton m squared. So, to calculate, we have 10 divided by pi over 4, okay, and then multiplied by 0.03 squared, okay, equal sign 14147, okay, 14147 kilonewtons per mm squared. And then for the shearing stress, shear, that is force over area, again using the basic relationship, pagka meron tayong torque, we have 16t over pi d cube. Alright, so 16 multiplied by the torque value, which is 60 Newton meter. Tapos meron tayong pi, again 0.03 cube, equal sign. Remember na meron tayo ditong newtons lang, ha? Newton per mm squared tayo dito. Okay, so we have 16 multiplied by 60 divided by pi multiplied by 0.03 and then cube, equal sign. Over 1,000 lang natin to para maging kilonewton. Okay, so 11317. 11317, this time kilonewton per m squared. So, palitan ko lang to. Dapat ay meters squared. Now, we have tension and then shear stress. So, pagka ginamitan natin ng ating formula using the principal stress relationship, remember this, maximum principal stress and minimum principal stress is equivalent to the stress element, okay, over 2 plus and minus, and then stress element over 2 squared plus the shear stress, okay, squared. So, this time, this one is represented by the tension, and then wala tayong compression. So, this must be equivalent to 0. Therefore, to get the maximum principal stress, I'll just put this value, okay? So, we have the tension of 14147 over 2. Again, ang unit is kilonewton per meter squared, that is kilopascal. Then, plus the same. Okay, so we have 14147 minus 0 over 2 squared, and then plus the shear stress of 11317 squared. So this one is the maximum principal stress in kilonewtons per m squared or kilopascal or kilopascal. Ang mga sagot is naka-megapascal. So, ibig sabihin over 1,000 lang. Alright? So, 14147 divided by 2, then plus square root of 14147 over 2. Dapat naka-square ito. Okay? Squared. And then plus 11317. Okay? 7 squared. Equal sign. So, 20.419. 20.419. So, over 1,000 lang para maging megapascal. So, we have 20.419. That is again for the maximum principal stress. Ngayon, sa minimum, change lang natin ito ng negative. So, lagyan natin 14147 divided by 2 minus this part 14147 divided by 2 tapos square plus 11317 squared equal sign. So, mali ito. Negative 6273. Okay? 73. Or 6 point ito, sorry. Naka-megapascal. Divided by 1,000. Okay, so negative 6.27 megapascal. Again, this is the minimum shear stress. So the answer here is letter B. Okay, problem number 4. Determine the orientation and normal principal stresses for the following stress states. We have the stress element on the x-axis equals to negative 10 megapascal, and the y stress element is equivalent to 210 megapascal, and the shearing stress is negative 15 megapascal. So this one is easy. Figure and data, since alam na natin yung relationship to get the principal stress. So pwede kong ilagay na ito yung ating stress element. Ito yung ating plane, and this is our y, and then x, this must be in this direction. So stress element on the x-axis is having negative 10 megapascal, tapos ito ay merong tension, equal sign 210 megapascal, and then meron tayong negative 15 na shear stress. So pwede natin ilagay dito, negative 15 megapascal. So, solution, again, of course, you can use your Mohr circle to find the value of the principal stresses as well as yung orientation. But now, we can try to use this one, okay? So, maximum principal stress and minimum principal stress is equivalent to the average over 2 of the stress elements plus or minus the square root of the same squared plus the shear stress squared. So again, plus for the maximum and then minus for the minimum. Okay, so this one is 15 megapascal equal sign. So again, for the maximum principal stress is equivalent to, again, using the positive, stress element on the x-axis plus the stress element on the y over 2 plus this part, stress element on the x-axis minus stress element on the y-axis over 2 squared plus the shear stress. Okay, so apply the values. We have negative 10 plus 210 megapascal over 2, and then this part, negative 10 minus 210 squared over 2 plus negative 15 squared. So maximum principal stress is in terms of megapascal. So minus 10 plus 210 over 2 plus square root of negative 10 minus 210 over 2, and then squared plus minus 15 squared equal sign. So we have 211.01 megapascal. Now for the minimum principal stress, so pwede natin gamitin yung same relationship, but this time gagamitin natin yung negative dito sa part na to. So minus, then equal sign, negative 11.01 negative 11.01 megapascal. So may hint na tayo kung ano yung magiging sagot. That is letter B. So we have 211 positive maximum principal stress, and then minimum principal stress is negative 11 megapascal. But then take note, pinapahanap din yung ating orientation, and as mentioned earlier or dun sa notes natin, we have this relationship that is 2 multiplied by the phi angle with respect to plane is tangent negative 1, 2 multiplied by the shear stress xy, tapos dito sa baba is x minus y. So ang hinahanap dito is yung 2 theta p. So 2 and then tan negative 1, 2 multiplied by negative 15 megapascal. Tapos yung x natin dito is 10 or negative 10, positive 210. Okay, so this is the value of the angle or the orientation. So shift tangent, okay, and then fraction 2 multiplied by negative 15, tapos negative 10 minus 210. So, equal sign. So, 7.76. 7.76 degree. So, ibig sabihin yan, if we have this y and x axis, okay, so normally, ang sign convention natin is kapag i-rotate natin yung ating principal stress, okay, with respect dun sa plane x, so counterclockwise is positive and then clockwise is negative. So, kung ito yung ating stress, maximum principal stress with respect to this angle or to this plane. So, ito yung ating 7.76 degree. Which means, kung ito yung ating maximum principal stress, we have to rotate this counterclockwise so that magiging horizontal na siya with respect or zero angle with respect dun sa x. So, again, this is the answer. Alright, so problem number 5. A circle of 200 mm diameter is inscribed on a mild steel plate before it is stressed. After stressing the circle, it deforms to an ellipse due to the stress element on the x-axis equals 260 meganewton per meter squared, that is the tensile, and then we have the stress element on the y equals to 15 meganewton per meter squared, which is compression, and the shear stress is equivalent to 20 megapascal. So calculate the lengths of the major and minor axis of an ellipse and find their directions. So yung major and minor lengths dito will be equivalent to the principal stresses, okay, and then pinapahanap din yung direction ng principal stress. So, almost the same kanina. To solve for this problem, figure and data. So, ilagay ko lang ulit yung mga stress element dun sa ating plane. Okay? So, let's take this as our x and then y. Alright? So, meron tayong stress element. So, in the x direction, is equivalent to 60. So, ito ay 60 meganewton per mm squared. And then, meron tayong compression. Okay, so positive. We have this value, 15 m per meter squared. And then, meron tayong principal stress, which is 20 megapascal. Alright, so initially, kung ito yung ating circle na 200 mm, so ngayon, nagkaroon tayo ng stress dito, wherein naging ellipse na siya because of this stress. So, ito lang yung simple illustration ng problem. So now, to solve for the maximum and minimum principal stress, so we have the same relationship. Again, pwede nating isolve ito using the Morse circle. But then, para madali, we can use this relationship, yung derived na equation natin. This is y over 2 plus or minus, and then we have x, and then y over 2 squared plus tau, which is actually the shear stress. And then, for the maximum, we have equal sign tong relationship na to using the plus. So again, this is our stress element on the x-axis and then ito yung ating stress element sa y-axis. So that is 60 plus 15 over 2 plus we have 60 minus 15 and then squared over 2 plus the shear stress is 20 megapascal. Okay, so that is our maximum principal stress. So 60 plus 1.5 over 2 and then plus open and then 60 minus 1.5 over 2 and then squared plus 20 squared equal sign 67.6 meganewton per m squared or megapascal. So now for the minimum stress, okay, same relationship dito ko nagagawin. Minimum principal stress, we can use negative. So same lang yung ating arrangement. We will just change this into negative. So again, negative sign here represents the minimum principal stress. Equal sign, we have 7.39 megapascal. And now for the direction, kanina nasolve na natin with respect to plane. So we have this 2 shear stress and then this one minus this one. So 2p means the orientation ng ating principal stress. 2p is equivalent to again 2 multiplied by 20 tapos 60 minus 1.5. So we'll keep it like this in terms of degrees. Sorry, this must be tan negative 1 or shift tangent. So therefore we have shift tangent, okay, 2 multiplied by 20 over 60 minus 1/5. Alright? Equal sign 41.63. 41.63 degrees. So, pagka hinanap natin dito yan, that is more or less letter C. That is 67.6 for the maximum principal stress. And then 7.4, 7.39 is the minimum principal stress, and the angle of orientation of the principal stress is 41. So, again, we have to rotate. If this is the plane axis, X and Y. So, ito yan. Probably nandito naglalayo ang ating principal stress. So, we have to rotate this counterclockwise 41 degree para yung ating principal stress is nasa X-axis na. So, again, the answer here is letter C. Alright, problem number 6. Find the orientation of principal and shear stress given stress elements at x-axis equals to 90 meganewton per meter squared, that is tensile stress, and then y direction or vertical axis equals to negative 60 meganewton per meter squared, that is compression, and the shear stress is equivalent to 20 megapascal. So for this problem, I will try to show different ways or different kinds of formula in order to solve this problem. I'll use Mohr circle as well as this equation. So kanina, yung mga previous problem natin, ginamitan ko ng Mohr circle. So ganun din dito. Try ko muna yung ating Mohr circle. Alright, so let's take this as our plane bago natin lagay dun sa ating shear and principal stress axis. Lagay ko muna yung X and then Y. Okay, so para clear. So first is meron tayong tension that is equivalent to 90 meganewton mn, capital letter N, meter squared. And then meron tayong compression. Negative sign sa sign convention natin. Pagka compression, dapat towards doon sa element. And this one is equivalent to negative 60 meganewton per meter squared, and then we have a positive shear. Again, nandito yung ating direction. That is xy equals to 20 megapascal. So now, para maging equilibrium, pwede tayo maglagay dito ng y. Tapos dito naman is meron ding tension. Tapos may shear stress ka dito. Alright? So that is yung representation ng ating stress dun sa x and y axis. Now, pagka nalagay natin yung, or pag ginamit natin yung Mohr circle, using Mohr circle, MC na lang. Okay, so lagay ko lang dito. Itong mga stresses na to, lalagay ko lang dun sa ating Mohr circle. Again, normally, we represent yung x-axis natin dito ng ating principal stress. And then yung vertical axis going down, we take this as positive shear. This one is negative shear. This one is positive. And this one is negative principal stress. So, yung x natin is 90. So, if this one is the origin, so let's take this as 0, 0. So, 90. Let's take this as 50. And then meron tayong 100. So, somewhere here, we have this point. Okay, so lagyan natin equals to 90 meganewton per meter squared. And then meron tayong negative 60. Again, this one goes to the left. So this one is 50. Let's take this as negative 60 meganewton per meter squared. And then meron tayong positive shear na 20. So again, 50. Let's take this as our 20 megapascal. Megapascal, again, MPa is equivalent to Newton per mm squared. Okay, so pwede natin convert ito mamaya. So for now, connect natin yung mga dots. So first is meron tayong 90. Ito yung ating first point. This one is 90 and then 20. So this one is the x component. And this one is the shear stress, positive. And then, we have negative 20 megapascal. That is somewhere here. So, pagka kinonect natin, ito yung ating y component. And this one is the negative shear. Then, this point is equivalent to negative 60 and negative 20 megapascal. Now, next procedure is of course to connect, okay, these 2 points para makita. So, I will use blue and here is the line. And yung Mohr circle natin, imaginary line, can be this. So, itong point na yan is naglalay doon sa circumference ng circle natin. Alright, so by using yung formula natin kanina or by inspection, pwede natin makuha yung center which is lying on the principal stress axis and then yung radius. So kanina, we have this. The center is basically equivalent to yung ating x component tapos y or the average. This one is the average. Okay, so stress average. Therefore, this one is 90 and then plus minus 60 over 2. Then the center of the circle is basically 90 minus 60 is 30 over 2. We have 15. Okay, 15 megapascal. So, diniretso ko na, no? Yung meganewton per meter squared is megapascal. So, this one is 15 and then 0 yung equivalent na shear stress. Alright? Then, ano yung radius? So, ang radius ulit is pwede natin gamitan ng Pythagorean theorem. So, kung ito yung point na yan, kung i-extract natin ito, note, meron tayong gantong drawing. So, if this one is 90, tapos ito ay 15, then this difference is 90 minus 15. So, that is around 75 megapascal. Then, mula dito hanggang dito is 20 megapascal. So, ang radius natin basically is equivalent dun sa hypotenuse nitong ating right triangle. Okay, and in order to get this value of r, we simply have to get the square of these two sides. Tapos, i-square root natin. So, therefore, r is equivalent to 75 squared plus 20 squared. And then, raise ko lang sa 0.5. That is 77.6 megapascal. So, again, you can use this technique, yung more circle, in order to get the answer. Now, ang next natin solution is ito. Alright? So, paano natin gagamitin yan? Dito, sa formula na to, that is actually the equivalent principal or the maximum principal stress. And this one is the minimum principal stress. So, ito yung ating relationship. But, before we can use this, we have to get yung ating angle. So, kanina, ito yung angle na yan. Mula dun sa ating horizontal axis, ito yan. So, this one, this formula is referring to the orientation for the principal stress. Meron tayong P, that is the principal, and then yung S naman is for the shear, orientation of maximum shear stress. So, itong angle na yan, dito is nire-represent ng 2P. In this case, principal stress. And then, ito naman, magmula sa vertical axis, this one is 2PS. That is the shear stress. So, try natin. First, kunin natin yung theta. So, paano natin makakuha itong theta dito? Again, take note, this one is equivalent to 2 theta P. Okay, so ito na yung ating equation dyan. We can use this one in order to get this 2 theta P. Okay, so solution B. Try natin kung ma-solve natin yung angle and kung tama ba yung sagot natin using this formula. Okay, so again, take note, ang hinahanap lang natin dito is yung angle, but then for learning purposes, let's try to use this equation 2. So, 2P is equivalent to the negative 1, tapos 2 multiplied by the shear stress, tapos yung ating stress element sa x and y. So, 2P is tan negative 1, 2 multiplied by 20, this one is given, and this one is 90 minus negative 60. So, ito yung angle. Alright, so meron tayong shift tangent, and then we have 2 multiplied by 20 over 90 plus, okay, negative multiplied by negative is plus 60. And then, equal sign, 14.93. So, this means that itong principal axis is lying 14.93. Take note, this one is degree and then positive. Okay, in order to make this line, this principal line, doon sa horizontal, we have to rotate this maximum principal stress by 14.93 in order to be in the same line ng ating principal stress or yung ating x-axis. Alright, so ito yung isang sagot dyan. So meron tayong 14.93 as an answer doon sa ating angle for the principal stress. Then, to solve for 2 theta S, that is the shear stress. Okay, binaliktad lang. That is the stress element on the x-axis minus stress element on the y-axis over 2 multiplied by the shear stress. So, this one is tangent negative 1 Tapos meron tayong 90 minus 60. Tapos 2 multiplied by 20. Alright, so shift tangent, and then 90 plus 60 over 2 multiplied by 20 equal sign. So 75.06, 75.06 degree. So ito yung ating sagot, which is actually letter A. Okay, so babaguhin ko lang yung final answer dito. This one is actually dinivide sa 2. So this must be 14 point something and this one must be 75 something. Now, try nating gamitin ito. Kung makakuha natin yung principal stress. Okay, so take note, this one is equivalent to the maximum principal stress. So lagay ko lang dito, equal sign. This one is stress element on the x-axis, that is 90 plus minus 60 over 2. Tapos plus, again, meron tayong 90 plus minus 60 over 2 multiplied by cosine 2p. Ang 2p natin dito is 14.93. 14.93 degree. And then meron tayong plus, okay, shear stress na 20 multiplied by sine 2p, which is again 14.93. So this one is equivalent to the maximum principal stress. So, tingnan natin kung pareho ang sagot. Okay, so tuloy-tuloy lang. 90 minus 60 over 2 and then plus 90 minus 60 over 2 and then cosine 14.93 and then plus 20 sine 14.93. Dapat ang makuha natin sagot dito is ito. Is equivalent dun sa maximum principal stress. Hindi pala natin na solve, but this must be equivalent to, oops, mali. Dapat ito ay positive. So this one is positive. Okay, plus. So take note dito sa formula, minus to. Minus. Okay, so this one must be plus. Okay, kasi minus multiplied by minus 60 is positive. So the maximum principal stress is 92. Okay, so lagay ko lang, maximum is 92 point something, 62 megapascal. Now, gamitin natin itong minimum principal stress. Okay, so but this time, take note, minus to, tapos minus ito. Alright, so baguhin lang natin yung sign. This must be minus. Ito naman is minus din. Para makuha natin yung minimum. Minus equal sign. Negative 62.6. Negative 62.6 megapascal. So again, ang ginamit natin dito is itong dalawang equations. Okay, this one and this one. Now, remember kanina, or yun sa previous problems natin, para makuha natin yung ating maximum principal stress using the Moore is we have the C plus the R. Okay, that is the center. In this case, we have 15. And then yung pinaka-radius natin as calculated is 77.6 megapascal. So therefore, we have 15 plus 77.6 equal sign. We have 92.6 megapascal. So again, balikan natin ito. 92.62. So pareho lang. Then, the minimum principal stress is basically C minus R. That is the center, 15 equal sign minus 77.6. Again, the unit of this is in terms of megapascal. Equal sign, 15 minus 77.6. So we have 62.6 megapascal, which is equivalent nito. So, this means that we can use the Morse equation as well as yung plane stress transformation equations in order to solve for the maximum principal stress given the angles. Okay, so again, nagkaroon lang tayo ng detour in order to use this equation. Pero ang pinakasagot dito is yung 14.93 and then 75.06. Okay, so the answer here again is letter A. Next problem, a solid shaft of 100 mm in diameter in a small hydraulic turbine is subject to an actual compressive load of 100 pi newtons and torque of 5 pi times 10 to the 6 newton meter. The maximum shearing stress induced in the shaft is blank. Use the maximum principal stress theory. Okay, so this method, this maximum principal stress is the same as we discussed earlier using the Mohr circle. So iba lang yung term na ginamit dito. So take note, this one is also called the maximum normal stress theory or MNS or Rankine theory. Okay, so this is the beginning of failure analysis, yung Rankine theory. So take note, sa Rankine theory, almost the same representation kanina. So we have the X component, a stress element on the X axis, and then we have the Y, which is normally represented by compression. This one is tension. And then here we have the shear stress. And in order to calculate for the maximum minimum normal principal stresses, we have this one. Okay, this one is equivalent to the maximum principal stress, and this one is equivalent to the minimum principal stress. Now, for the minimum and maximum shear stresses, we can use this formula. Again, the positive refers to the maximum shear stress. This one is maximum and this one is minimum shear stress. Okay, pagka ginamit natin yung negative, and then dito naman is positive. Okay, pagka ginamit natin itong formula na to. Alright, so we have two load. Lagay ko lang figure and data. Figure and data. So meron tayong hydraulic turbine wherein, let's take this as our shaft. Okay, so at the end of the shaft meron tayong hydraulic turbine. So kunwari ito yung ating impeller. Okay, so pwede maging Kaplan turbine yan. So yung tubig is nag-flow dito. Okay, and this flow creates rotational direction doon sa ating impeller and therefore doon sa shaft. Okay, so yung shaft is basically subjected to torsional stress or shear stress. And then, take note, ito ay may load because of the direction of the water going in here. This one is na-subject doon sa axial load, and this axial load is represented as compressive load. So again, take note, when you say axial load, pwedeng maging tension or maging compression. Alright, so in order to solve for the maximum shearing stress, we can use this equation. So same lang yung representation. Alright, so first of all, meron tayong axial load of 100 pi newton, and then meron tayong torque. Okay, that is the torque here, torsion stress, 5 pi times 10 to the 6 Newton meter. So ito usually ginagamit natin sa torsional analysis in actual practice. Alright, so in order to get this, yung maximum shearing stress, we have to calculate first yung ating shearing stress due to this torque, and then yung ating compressive stress. Okay, so by the way, ang diameter nung shaft, so ito yung umiikot, alright, ito yung ating shaft. So this one, diameter is 100 mm. Okay, so doon sa ating basic formula ng stress, solution na tayo, no? Note that the normal stress, like ko lang, ito yung ating compressive, no, is equivalent to the force per unit area. Alright, so I can use this equation for sure. That is 100 pi newton over yung area natin dito. Since bilog yan, we can use yung pi over 4 diameter squared. Pi over 4 d squared. So therefore, this one is 100 mm squared. So therefore, we have blank newton per mm squared, which is basically megapascal. So we have, again, 100 multiplied by pi over 4 multiplied by 100, and then squared equal sign, we have 0.04. Okay, 0.04 newton per millimeter squared. And then for the shear stress, okay, shear stress is basically 16 t pi d cubed. So that is the shearing stress. SS normally ang representation. Okay, so given yung torque, we have 5 pi times 10 to the 6 newton Anong unit niyan? Newton meter. So we have to convert this into millimeter. 1 meter is 1,000 mm. Alright. And then over pi multiplied by 100 mm. This must be cube. So shearing stress is blank. This will cancel out. Meter. And then meron tayo mm cube dito. Alright. So we can cancel this one. And this will be in terms of meter squared. So we have again 16 times pi multiplied by pi exponent 6 over pi multiplied by 100 and then cube equal sign 80. This one is 80 newtons per mm squared. Okay, newton per mm squared. Ulitin lang natin ito just to make sure. Sa reference ko, I have dapat 40 yan. Try lang natin. So, pi divided by 4 multiplied by 100 squared equal sign 0.04 newtons per millimeter squared. Oops, small correction. This must be kilonewton. Okay, kaya pala 0.04. Masyadong mababa. This one is kilonewton. Kailangan pa natin i-convert ito. This one is kilonewton. Therefore, kung gusto natin maging newtons yan, we simply have to multiply this by 1,000 para maging newtons per mm squared. Because basically, 0.04 multiplied by 1,000 is 40 newton mm squared. Kasi pagka 0.04 ito, masyadong maliit as compared dun sa ating shear stress. So in this case, at least almost balanced. Okay, so 40 newtons per millimeter squared yung ating axial compression stress, and then meron tayong 80 newtons per millimeter squared para sa shear stress. Then we can use this formula now. That is, in order to get the maximum shear stress, then we use the positive. Alright, this one, x minus y over 2 squared plus the shear stress. Okay, xy squared. So in this case, 0 yung tension. Alright, tapos meron tayong compression. So lagay ko lang negative, walang problema dyan. We have 40 over 2, tapos squared natin. Again, ang unit natin dito sa loob is naka-newton per mm squared, which is basically megapascal. Plus, this one is 80 squared. So the maximum principal stress using the Rankine theory is equivalent to 40 over 2 and then squared plus 80 squared equal sign. We have 82.46. Okay, so 82.46 newton per mm squared or megapascal. Okay, MPa. So the answer here is letter A.